Today is a really good example of one of those days when I'm going to take a lot of the information that's in the book and I'm going to say, they give you all of this information, but this is the piece you need to know. So you may want to make sure that you have pencil and paper handy so that you can jot a few of these things down and so that you're not trying to memorize a whole bunch more stuff than you really have to memorize. We're talking about measurement today, and one of the first things that we need to talk about is the difference between qualitative and quantitative measurements, or qualitative and quantitative data, because there are two different kinds. And it also is going to fall into the classification of what kind of observations you are making. Qualitative data means that you don't have any numbers associated with what you're observing. So a qualitative observation or qualitative data might say, this solution is much colder than the other one. This fabric is very rough. This particular board is shorter than the other one. This bag of groceries is heavier than the other one. This pot has a lot more bubbles in it than the other one does. So you can see that I don't have any numbers at all, but I'm making some sort of observation, some sort of collecting some sort of data about the objects that I'm looking at, but I don't have anything really specific. However, if I said in place of this solution is really cold, I said it's 15 degrees Celsius, that tells me exactly how cold it is. If I say this board is short, versus I could say this board is 23 centimeters long. That's not a very long board. If I say this bag of groceries is really heavy, if I say it's 45 kilograms, well, that would be way too heavy for a bag of groceries, but you get the idea. Okay, so anytime that you have a quantitative measurement, it has numbers in it. And I remember the difference between these two words because the word quantitative has an N in it, and N is the same word that starts, or the same letter that starts with the word number. And so a quantitative measurement has a number in it. Now, what I want you to notice is that all of these measurements not only have a number, but they also have a unit. Whether the unit is degrees Celsius or centimeters or kilograms, the unit is very, very important. And any time that either on your test or in a lab notebook, in an experiment write-up, if you give me a number and you do not put a unit after it, you're going to have some points deducted, because without a unit, I don't know what you're talking about. Are you talking about kilograms? Are you talking about liters? Are you talking about dogs? Are you talking about gumballs? I don't know what you're talking about if you don't put a unit on your number. For example, if I tell my son, I want you to go meet me at this other house down the road, and we have to go separate places afterwards. So you get in your car and I'll get in my car, and we'll both go 6, and then we'll be at the right place. Well, 6 what? If I go 6 miles, but he goes 6 kilometers, we're not going to end up in the same place. So I have to specify 6 what in order for that to make any sense. So anytime you write a number, you want to make sure that you put a unit after it. Okay? There is a big page in your book that talks about fundamental units. In fact, it's page, let me see here. It's page 15. Talks about the fundamental, SI fundamental units, and there are 7 that they have listed. You do not need to know all 7 of them for the purpose of this class. There are only 3 that I expect you to know. The first one is that length, the fundamental unit is a meter. Mass, the fundamental unit is a kilogram. And time, the fundamental unit is a second. Now, that doesn't mean that we can't use other units. It's just that this is the standard one that we use. I mean, we may use kilometers or millimeters or centimeters. We may use any of those. We may also use hours or days or years if one of those others is appropriate. But this is considered the fundamental unit, and so this is something that you'll need to have memorized. Okay. They also, on the next page over, I believe that would be page 16, they have a whole bunch of metric prefixes that they expect you to, that the book expects you to know, Again, I do not expect you to know all of those prefixes. I am hoping that somewhere in your math classes you have studied the metric system before, and so maybe you already have a base knowledge of it. For this particular class, though, what you need to have memorized are the following. You need to know that 1 kilometer is 1,000 meters. You need to know that 1 meter is the same as 100 centimeters. You need to know that 1 meter is the same as 1,000 millimeters. And you need to know that 1 centimeter is the same as 10 millimeters, okay? Those you need to know just right off the top of your head, just like that, so that you're able to use them at the drop of a hat. Now, obviously, if you know that 1 kilometer is 1,000 meters, you're also going to know that 1 kilogram is 1,000 grams, and 1 kiloliter is 1,000 milliliters, 1,000 liters. So I do expect you to know these and to be able to use them. So again, if you need to pause the video real quick to jot down these fundamental units that you need to know and to jot down these conversions that you need to know. I think I'm standing out of the way right now, so if you want to pause it right now and write those things down, that would probably be a very good thing, so that you're not memorizing more than you need to. Okay. When you are making measurements, and you're going to be doing a couple of experiments at the end of this chapter where you're going to be doing some measuring, there are a couple of things that you want to keep in mind. When we talk about measurement, we talk about accuracy and we talk about precision. They use some bullseyes to help represent the difference between the two. I'm not a real big fan of that particular example to explain it, because I think it lacks a lot. But here's what you need to understand about accuracy and precision. First of all, accuracy is how close you are to the accepted value. So, for example, a football field for American football is 100 yards long. And so if you measure a football field and somebody measures the football field as 99.99 yards, and somebody else measures the football field as 103 yards, obviously one of those is a lot closer than the other. So because this value is the one that is closer to the accepted value of 100 yards, this one is the one that is more accurate. Now there is also precision. And precision has to do with how many decimal places there are in your measurement. And it completely depends on what measuring instrument you're using. And so if I look at these two measurements, this one has more places after the decimal point. They're both measured in yards, and so you have to make sure that that's the case first. But since both of them are measured in yards, this has 2 places after the decimal point, and this doesn't have any. So not only is this measurement more accurate, it is also more precise because it has more places after the decimal point. When you make a measurement yourself, you always want to make sure that the last digit you're using is actually estimated. And I'll show you here with a couple of examples what I mean by that. Let's assume that you have 2 different rulers. One of your rulers looks like this, and it's only marked off in, let's say that it's marked off in centimeters, okay? So 0, 1, 2, 3, and that's the only marks that are present on the ruler. So if I am measuring this red line underneath here, and I'm measuring that, I know for absolute certain that this line is between the 1 and the 2. The end of the red line is between the 1 and the 2. What I don't know is, obviously it's more than 1 and it's less than 2, but exactly where is it? Well, if I would estimate, I'm going to guess that it's about 1.4 centimeters, if these are measuring centimeters. So you can see that I estimated that last digit. I was trying to estimate about how far it was between those 2 marks, okay? Now, let's say that I'm measuring this line with this particular ruler, and again, these are going to be centimeters. I probably should have put that on there. I'm assuming both of them are centimeters. Now, please don't notice too much the fact that my ones are different in both of them. We'll just say that one of them I blew it up a little bit more. So now let's say this ruler is also in centimeters, and now I'm trying to measure the length of this line. Well, when I look at it, it's not only obviously between 1 and 2, it's also obviously between, this is marked off in tenths or in millimeters. So I can tell that it's between the 2 and the 3. There's really not too much doubt that it's between the 2 and the 3. The question is, how far between the 2 and the 3 is it? And when I look at it, it looks like it's awfully close to the 3, but maybe it's not quite all the way there. So when I use this ruler to measure it, I know that it's between 1 and 2, so I'm going to have 1, and then a decimal point. I know that it's between the 2/10 and the 3/10 mark, so I'm going to put a 2. That one I know for sure. How far between those two marks is it? Well, I have to estimate. I have to guess that last number. So it looks like maybe it's so close, and maybe it's a 9. You may look at it and you go, no, I think it's an 8. I think that's really what it is. Maybe that's an 8 over here. Maybe you looked at this one and said, really? I thought that was more like a 3. Well, that's okay, because the last unit in your measurement is estimated. It's uncertain. And so what I look at and what you look at, how you determine that last digit may be a little bit off, and that's okay. As long as our others are in agreement, we know that this one is the one that was estimated. So which one of these is more precise? Well, if I use this ruler, my answer is going to be more precise because it has 2 decimal places after it, in place of using this ruler where I just have 1 decimal place after it. So that's the difference between accuracy and precision. Accuracy is how close are you to what the accepted value is. Precision has to do all with your measuring instrument and how many decimal places can you get as far as the number that you can record with it. So when we come back together the next time, we're going to talk about some unit conversions and actually converting measurements from one form into another.